Section 7.3 deals with our double angle formulas and half angle formulas. There's a lot of other stuff within there, but we're just going to focus in on our double and half angle formulas. And what we have right here are double angle formulas. And so what those do is they tell you what the sine, cosine, tangent of 2 times angle u is, as long as we know what the sine, cosine, and tangents of angle u are. And so a good example of that would be right down here. It says if the cosine of x equals negative 2/3 and x is in quadrant 2, find the cosine of 2x and the sine of 2x. And so first thing I'm going to do in that situation is go into section or quadrant 2 and draw my triangle to represent this trig. I'm going to use my right triangle definitions. Cosine of x is negative 2/3. So adjacent is negative 2, hypotenuse is 3, and if we do a little work with our Pythagorean theorem, we find that this is the square root of 5. And so remember now, this is x, and this right here, angle in the triangle, is x bar, the reference angle. Alright, and so now we have a triangle, so I can find out what the sine, cosine, and tangent of x is. And so that gives me, as long as I know sine, cosine, and tangent of x, I can find sine, cosine, and tangent of 2 times x. And so let's go in and do the sine of 2x first. And so if you look at our formula here, sine of 2x equals 2 times the sine of x times the cosine of x, which is 2 times, now we go to our triangle, sine of x is negative 2/3. And I would say the number one thing you have to keep in mind here is sines. And right off the bat I made a mistake there. Negative 2/3 is the cosine of x. The sine of x is square root of 5/3. And so when we do this multiplication, we have a denominator of 9. And my numerator is going to be negative 4 square roots of 5. And so there is what the sine of 2x is as an exact answer. Negative 4 square roots of 5 over 9. Now when you look at the cosine of 2x, what you find is there's actually 3 different relationships there. Well, any of those 3 relationships will work for you. Just pick which one you want to use. Let's use the first one. Cosine squared x minus sine squared x. That is not a Pythagorean identity. Pythagorean identity would have a plus in between there. But the cosine of x was negative 2/3. We square that. Minus square root of 5/3. And we square that. Those are sine squareds there. Negative 2/3 squared is 4/9 minus 5/9 tells me that my cosine of 2x is negative 1/9. And since both sine of 2x and cosine of 2x are negative, we know that 2x is going to put us somewhere in the 3rd quadrant. Cosine of 3x in terms of cosine of x is what we're expected to do here. And so it doesn't seem like it would fit into our double angle formulas, but the first thing we would need to do here is take this cosine of 3x and rewrite it as an addition so that we can use some of our identities. And so first thing I'm going to do is rewrite this as cosine of 2x plus x so that I can use my cosine addition rule that says this is going to be equal to the cosine of 2x times the cosine of x minus the sine of 2x times the sine of x. And so now I can use my double angle formulas for sine and cosine. And so the cosine of 2x, once again, use any one that you would like. I think for this particular one I'm going to go with 2 times the cosine squared of x minus 1. Then that's going to be times the cosine of x. minus, and the sine of 2x is 2 sine x cosine x times the sine of x. I think it's natural at this point to want to distribute, so let's do that. And when we do that, we end up with 2 cosine cubed x minus cosine x minus 2 sine squared x cosine x. And so we're pretty close to being done here. We have a cosine cubed x, which is, it's in terms of cosine x, it's just being cubed, cosine x. But this term, we have a sine squared x. But we can easily get rid of that with our Pythagorean identity, because we know that sine squared x is 1 minus cosine squared x times cosine x. There's a minus here. And these two terms are just going to come down as is. We didn't do anything with them. And so now let's clean up this last term. I see two things that need to be distributed. A cosine x over the parentheses and a negative 2. And well, this will come with us. Minus cosine x. Now let's make sure we do this right. Negative 2 times 1 times cosine x is negative 2 cosine x. Negative 2 times negative cosine squared x times cosine x is plus 2 cosine cubed x. And now we have a couple terms that we can combine. 2 cosine cubed x plus 2 cosine cubed x is 4 cosine cubed x. Minus cosine x minus 2 cosine x is minus 3 cosine x. And so there is our end result. We just took the cosine of 3x and wrote it strictly in terms of cosine x. And what we got was 4 times cosine x cubed minus 3 times cosine x. Now what I would like to do here is kind of challenge you to see if you can prove this identity right here. And if you look at the left side, up on the top here, we do have the sine of 3x. And so I have a feeling that to be able to prove this identity here, we're going to have to kind of do something similar to get the sine of 3x down in terms of just sine of x or cosine x. So I'm going to offer extra credit for anyone that can go get themselves through this. To get extra credit, though, you need to have this done prior to your checkoff quiz. The half angle formulas, once again, if you know the sine, cosine, or tangent of angle A, then we can use these formulas to find the sine, cosine, or tangent of half the angle of that. And I think what you have to be careful of is both the sine and cosine, you have a decision to make in terms of positive or negative. And so ultimately the rule is right down here. The sign for positive or negative depends on what quadrant A divided by 2 lies in. Not where the original angle A lies in, but where does A divided by 2 lie in. And so I have two examples here I'd like to look at that. I'll clear that. So first one is find the exact value of the sine of 22.5 degrees. Well, what we need to do is be able to take 22.5 and how can we write that in terms of one of the angles that we know exactly on the unit circle. And what we could do there is treat it like this. The sine of 22.5 degrees equals, and let's rewrite it as the sine of 45 degrees divided by 2. And so in this particular setup, my A value is 45 degrees. And so that's what I'm going to be using in all of these formulas for A. Well, in this particular one, I'm only asked to find what the sine of 22.5 is. So I'm going to use the sine formula. And so now we have a decision to make. Is it going to be positive or negative? Well, 22.5 degrees is in the first quadrant, and sine is always positive, so I'm not even going to write it in. So we can just step right in and go to the square root of 1 minus, now the cosine of 45 degrees is square root of 2 over 2, and that goes all over 2 right there. Now this is an equal sign right here, not a z. Alright, so what we need to do here is kind of clean this up. And so I'm going to multiply both top and bottom of this by 2 over 2 to clear the fraction inside a fraction. So we still need some work there. And when I do that, I get the square root of 2 minus the square root of 2 all over 4. And I guess what I would do from here, you could probably leave it as that. In fact, I think that's what I would do right there, is just leave it as this. I don't think there's much you can do to simplify. I guess what you could do is, though, since square root of 4 is a perfect square, you could go square root of 2 minus the square root of 2 all over 2. But either of these are acceptable answers. And let's finish off with the last one here. Find the tangent of u over 2 if the sine of u is 2/5 and u is in quadrant 2. And so I'm going to go back in and deal with this right here. I'm going to go in and draw my triangle in quadrant 2. So I can use this triangle to find all my trig values. So the sine of this, once again, remember this is angle u, and there's the reference angle u bar. So 2/5 opposite over hypotenuse. And a little Pythagorean work, 25 minus 4, this is going to be the square root of 21. And realize, let's maybe put a little note, little reminder that it is negative x coordinate in the second quadrant. Alright, so we're asked to find tangent of u over 2. So as we look, there's two possible formulas you could use. Once again, I don't think it matters. In fact, I know it doesn't matter. And so let's go u over 2, that is supposed to be a u there, equals, and let's just use the first one. 1 minus, in this case it's going to be 1 minus the cosine of u, which is negative square root of 21/5, divided by the sine of angle u, which is 2/5. And so we have a lot of things going on here. Fractions inside fractions. We'll multiply by 5 over 5, the lowest common denominator of the inside fractions. I got minus a negative in here, and so I'm left with 5. I'm going to distribute plus the square root of 21 all over 2/5 times 5 is 2. And so the tangent, let me write this a little better here, of u over 2 equals 5 plus the square root of 21 all over 2.